roots of 2x plus 3 times x minus 4 plus 2x plus 3 times x minus 6 equals 0. 2x plus 3 times 2x minus 10 equals 0. So that would mean one of the roots is x equals 5, and another one is x equals minus 3 over 2, sum up to 7 over 2. So it's A. 2. Cindy was asked by her teacher to subtract 3 from a certain number and then divide the result by 9. Instead, because Cindy is special, she subtracted 9 and then divided the result by 3, giving her an answer of 43. What would the answer have been had she worked the problem out correctly? Okay, Cindy, we know you belong in SPED, but... So, 129 was x plus 9, so x, the number, was probably originally 120. So she was asked to subtract 3 from this and then divide it by a certain number. Oh my goodness me gracious. 1 sec. Okay, so, back to the point, let's see. 1, 3. Okay, that's weird. That's not what any of the options. Wait, okay, so x minus 9 over 3 is 43. What is x minus 3 over 9? Oh, so x minus 9 is 129. So x is 138. So that means 138 over 135 over 9 is a good fat hunk. 45 times 3 over 9 is 15. A.
Keep your tissues on the bottom shelf. The second shelf. Here.
3. According to the standard convention for exponentiation, if the order in which the exponentiation performed is changed.
Okay. Good luck.
Thank you. Oh, is it only 2 to the 8 and 2 to the 16? Oh. 4 to the 4, which is also 2 to the 8. Yeah, I'm pretty confident there's only one other value. Complement is 25% of its supplement. So we have some angle theta. This is its supplement, and this is its complement. So apparently 90 minus theta is equal. Yeah. Is equal to 1/4 180 minus theta. Damn, these line napkins are finished. 45. So now we just do theta is 45 times 4/3, which is about 60. Okay, each of the small circles in the figure has radius Luna. On the innermost circle, okay, innermost circle is, oh, that's easy. Well, the radius of this innermost circle is just 3, because 1, 2, and then that means that the area is 9 pi, and there are 6 little circles, so 3 pi is the area of the shaded regions. How many positive integers m? Those are decimals. N, that m dot n, m times n is less than or equal to m plus n. Hmm. Well, yeah, because even if you pick any integer for m, like 27,000, you can just set n to be 1 and it'll always work. Because 1 is the identity for multiplication, so you'll just have 27,000 on this side, and then you'll have 27,001 on the other side. Or you could just go ballistic and set m to whatever you want and n to, wait, no, but that's not a positive integer. So yeah, there are infinitely many. Right? Yeah. "45-degree arc of circle A equal in length to a..." Okay. So 1/8, I think that's it. Anyway, yeah, 1/8 of 2 pi r A is equal to 1/12 times 2 pi r B. So we have this, then we have 12/8 RA is RB, so 3/2 RA is RB. So pi RA squared is equal to, well, pi RA squared is the regular, and then we have 9/4 pi RA squared for circle B. So the ratio is 4 to 9, or wait, circle A's area? Circle B's 4 to 9. Ooh, da, 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 da. Betsy designed the flag using blue triangles, small white squares, and a red center square, as shown. Let B be the total area of the blue triangles, W the total area of the white squares, and R the area of the red square. Which of the following is correct? So, let's see. Let's try cutting out a little picture of it. So like 1/4 of it over here. So then we have a big fat hunk of red in the corner. You made me homeless. Now I'm running on the streets. No. Oh, I put them in the wrong space.
How's it going?
Not good.
Why?
Enlighten me. Whoa. Mod problem 8 and already struggle is real. Whoa. I just realized you could like connect these two blue pieces to make one of these fat blue pieces. So you could have 3 of these fat triangles, and each triangle makes up 1/8. I'm basing this off of assumptions that I'm getting visually, because they don't actually tell you anything. Oh, actually, yeah, you know what? The blue and white area are the same. So that's 3/8, right? Now this tiny little fella right here is 1/16.
See, we're trying to face this way. If you can, maybe.
If we double this, we get 1/8. But if we double that second time, we get 1/4. This rectangle. So we're getting 2/8 plus 1/8, which is also 3/8.
Here, take these.
Thank you.
Put them in the second field.
So yeah, that's sorta, maybe, kinda, and this is 1/4 based on my visual assumptions. So yeah, I'm going to say the B equals WA. Okay. Seven MB up 0.4 MB. Okay. Let's see. How can we optimize disk storing over here? 1.44 megabytes of space. We could use 6 of them just to fit all of the 12 files. Okay, and then we have 15 files that take up 0.4 MB. Well, now that I think about it, actually, instead of doing that to use up every single one, we could put one of these, and honestly, The rest take up 0.4, so we could put one of these as well in there. So that's 1.1 megabytes of space. Wait, no. You could use, you could put the 0.8 and 0.4 ones in one disk for 3 disks. Then you have 12 more disks to put in the 0.7s and the 0.4s. So I'll say 15. Besides, what is the sum of all of the space? 2.4, 0.84, no, 8.4, and the rest take up 0.4. That's 15 times, so 6. So that's in total 8.4 plus 8.4, which is 16.8. Now 1680 over 144 would be like an insane number. So let's see, 6. Oh, would you look at that? It isn't even divisible. But from what we can squeeze out of it, I'm getting about 11 disks. Okay, that's kind of sketchy. But regardless, we can't it's because we can't squeeze in some extra files into 0.01 megabytes of space left. I'm pretty confident that it's D, but let me see if I can find a different configuration that could possibly fit more. Okay. What if we use the 3 with the 0.4 and 0.8? That means we have 12.7 and 12.4s left. Then we use 6 more to completely purge the 0.7 files, and the rest take up 0.4 megabytes. So how many could you fit into one of these bad boys? You could fit 4. So after 3, this could be 0 as well. So 3 plus 3 plus 6 is 12. That is actually the minimum number of disks. And I'll show you, in fact, what each disk contains. So the first 3 disks, 0.8, 0.4, 0.8, 0.4, 0.8, 0.4. And then when we move on to the second disk, when we move on to the fourth disk, it's 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, and 0.7. That's all of our 0.7 files exhausted. And now we can put 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4. And there we go. That's all of it exhausted in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 disks. Now, it would be insane if the answer was like 13 or something like that. So, does this take up more space than allowed? What? What the heck? Oh, I miscounted. Yeah, this is 9. Oh, darn it. That was one error, but it's okay. Mm-hmm. So that's 3 over 5 ounces are coffee. So 2 and 5 is cream. Let's see. Mr. Early Bird gets up every day at 8 a.m. Okay. So let's say he needs to get to work in T minutes. All right. So, the distance away is D. So if D over D over T plus 3. Okay. So if the velocity is 40, so then distance divided by 40 is T plus 3. And distance divided by 6 divided by N is T. What is N? Oh, D plus 120 over 40. Well, D minus 120 over 40 is equal to D plus 180 over 60. So 60D minus 7200 is equal to 40D plus 7200. Wait, what the heck? Processing. Wait, no, they're of opposite signs. You can't cancel them out. Okay, so that's D. I'm pretty sure this is in miles. That's a decently long commute to work, but I mean, whatever you want to do, buddy. T plus 3, 720 over 60 is T minus 3. So this is 12, right? And this is 18, and yes. So he needs to arrive in exactly 15 minutes. Wow, he is speeding. Well, no, 15 hours. So that means that 720 over x is 15. So x is 720 over 15. So this is 65. 70. Wait, what the heck? No. 65 isn't a multiple. 60, 120 minus 120. 48. 48 miles per hour. Okay, both roots of the quadratic equation x squared minus 64x plus k are prime. So the value of k is, I know this is like a V8 formula problem, but I don't care. So we need to make it such that 63 minus n over 2 is prime, and 63 plus n over 2 is also prime. My gosh. My gosh, these teachers. Is equal to P1 equals P2. Two times P2 minus P1. So n is the difference between these two primes. No. Oh wait, no. A minus. Oh, that's just a quadratic. It's just the two different solutions of a quadratic being summed together. 1 plus minus square root of 2. So it's 1 plus minus rad 5 over 2. So it's 1. Why? 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 What I need today. So it's like 2 log 2002n. So 2 times log 2002 times 2 will be some more. Oh, yeah, that's easy. And the log of a number itself is just 1. 2, maybe. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So A, B, C. What we could do here for the to knock off the unique mean and mode here would be put 8. So now the average of these two is 8, and the mode is also 8, given that we don't use any others. H over 8 is 8. A plus B plus C plus F plus G plus H is 4D8. So I gotta make these as small as I can without making another mode. Oh, 8 integers? Oh, I know just what I'm gonna do. Oh, the range? Oh, shoot. Not 10, but 8, so 40. So we're trying to maximize A in honesty. So this will be 7, 6, and then 5. So I think that 5 plus 8 is 13. That's the largest integer that can be part of this. You know. So if Sergio gets 1 or 2, it's game over. So that's a 1 in 5 chance of a game over. And if Sergio gets 1 in 10, he wins, obviously. Wait, so what is every number Tina can make with that set? And what is the chance that it'll happen? So she could make it with 1 and 2, or with 2 and 1. And that's 3. You could make this with 1 and 3, or 3 and 1, which is 4. Can't make it with 2 and 2 because they gotta be distinct. I could make this with 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1. This is 5. I could make this with 1 plus 5. What time is it? Okay, I'm checking. So we have 10 minutes until we gotta go. Hopefully we can solve this last problem. Six. Now 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2. This makes 7. Then 2 plus 6, 3 plus 5, 5 plus 3, 6 plus 2 is 8. 2 plus 7, wait, 2 plus 6? Oh no. Can't use 6 here. We've got 1 to 5. And finally, we've got 9. 3 plus 6, 4 plus 5, and 5 plus 4. How many what probability is it that you select just any given pair? 1 in 5 times 1 in 4 is 20. Well, this has a 2 in 20 chance, another 2 in 20 chance, a 4 in 20 chance, another 4 in 20 chance, yet another 4 in 20 chance, and then a 2 in 20 chance, and another 2 in 20 chance. And that adds up to 20. Or 1, technically. So 2 in 20, or let's put just 1 in 10 times the chance that Sergio's number is larger, so exceeds. So it can't be 3 anymore. It's got to be 4 through 10. So 4, 5, 6, 7, 8, 9, 10. 7 numbers. So there's a 7 in 10 probability Sergio wins when that happens. So 1 in 10 times a 6 in 10 probability, well, plus, not times, plus 2 in 10, or 1 in 5, I guess. 1 in 5 times a 5 in 10 chance. Then 1 in 5 times a 4 in 10 chance. Plus 1 in 5 times a 3 in 10 chance. So there's a 1 in 10 chance, and then a 2 in 10 chance Sergio wins, and a 1 in 10 chance, and a 1 in 10 chance Sergio wins. Wow, okay. So simplifying. 7 over 100 plus 6 over 100 plus 1 over 10 plus 4 over 50, so I'll just make that 8 over 100 plus 6 over 100 plus 2 over 100 plus 1 over 100. So 10 plus 6 plus 6 plus 8 plus 2, 10, 18 over 100, which is a grand total 40 and 100 chance, which is 2 and 5. Alright, let me go check the time. A few more minutes left. Okay. Okay, so how do we pack these fellows up such that they use each of the 9 non-zero digits exactly once? Single digit 1, then to optimize, now we need to use 1, 4, 6, 8, and 9. So inevitably, we'll have to pick things like 41. Exactly once. Now that leads us to an impossible decision to make over here. Because now we have 6, 8, and 9, and we can't make anything with that. Yeah, okay. So let's go back to the drawing board. We're going to leave 1 single digit prime to be used. Actually, just 2 single digit primes to be used. So now we have 1, 4, 5, 6, 7, 8, 9. So we could very well do 41. So sorry. 59 and 67, but that leaves 8. Okay, so then let's make this 83. This is really big, but it's the best I could do. And a 150, a 252. Yeah, that's the smallest that I could get. C1 and C2 be defined by I'll do these after my NYU classes. So thank you everybody for watching, and we'll finish this AMC in the afternoon. Bye.